Today we are going to talk about solving equations using multiplication or division. A quick review. To solve means to find the unknown value. An equation is two expressions that are equal to each other. So for example, 9 plus 3 is an expression, 12 is an expression. They have the same value. X plus 7 is equal to 15. This is an equation. We would solve this equation to find what X is to make this true. And then lastly, solution. Solution is the value that makes the statement true. So for example, an X plus 3 equals 7, the solution that makes this equation true is X equals 4. When we solve equations, our goal is to isolate the variable. When we solve equations, our goal is to isolate the variable. What is our goal when we're solving equations? Isolate the variable. All right, so today we are going to talk about showing our work. Yes, I do understand that some of these are easy to do in our head, but we will get to the more complicated ones. So I do need you to know how to efficiently solve your equations, and that includes showing your work. So you'll start by boxing the variable and draw your line down from the equal sign. And then you will ask yourself in step number 2, how can I isolate the variable? So how can I get the variable alone? I get the variable alone by using inverse operations. I use the inverse. The inverse of multiplication is division, and the inverse of division is multiplication. Whatever you do to one side of an equation, you must do to the other side. We need to keep this balanced, okay? And then lastly, we will check our answer by substituting our solution back into the problem for the variable. So yes, there are several steps here to complete. We will complete all of these steps every single time to make sure that we are doing our work efficiently, to get in that best habits. So when we move on to 2, 3, and more step equations, we are ready. All right, so let's go ahead. We are going to try 4 problems together. We will start up here with negative 2x equals 18. So I'm going to box that variable, and I'm going to draw my line down. Now I have to ask myself, okay, what can I do to isolate the variable? How do I get this x by itself? So I do that by saying, okay, what is the inverse that I need? What is the operation that is occurring? Well, occurring right now is multiplication, negative 2 times x. The inverse of that is to divide. So I divide by negative 2. Make sure you do not forget to bring down that negative. It's attached to that 2. So negative 2 divided by negative 2 gets us 1, so that leaves us with just x. But step 3 tells us whatever I do to this side, I need to do to this side. So I also need to divide by negative 2 over here. X is all that's left here. I evaluate 18 divided by negative 2, getting me negative 9. This right here is our solution. But now I want to make sure that this solution works. So I take my expression, negative 2x equals 18, and I take that negative 9 and I substitute it in for that x. So now I have negative 2 times negative 9. Does that equal 18? Sure does. 2 negatives make a positive, and 2 times 9 is 18. So this is correct. That means that my solution is good to go. All right, let's try another problem here. Again, I can start by boxing my variable and drawing my line. This line shows my balance. It helps remind me that whatever I do over here, I must do over here. Step 2 is to ask myself how I can isolate that variable, that number in that box, or excuse me, that variable in that box. So I notice here that we're doing x divided by -3. So to inverse that, I need to multiply by -3. -3 times -3 gets me x by itself. I must multiply over here by -3. And I'm left with -4 times -3 equals +12. Again, that's my solution, but I'm not done yet. I need to prove that my solution works. So I rewrite my equation, 12 divided by -3 equals -4. 12 divided by -3, -4, -4, check. My solution is correct. This is the solution I'm looking for. This is how I prove it. We've got 2 more problems here today. Let's start with this one. This one's a little bit different, okay? So I'm going to start by boxing my variable 1/2 of x and draw my line. Now, why is this different? Because we have 1/2 being multiplied by x. The inverse of multiplication is division. So technically what we're going to do is take x divided by 1/2. But what that really means using KCF is that I keep my x, multiply by the reciprocal. So actually what I'm doing here is multiplying this by 2/1. So this part I don't need to show, but I do need to recognize that when I'm inverting a multiplication of a fraction, that I actually multiply by the reciprocal. Now 2 and 1 cancel each other out. I am now left with my x. I need to do that on this side too. So 8/1. 8 times 2 is 16/1, leaving me with 16 as my solution. Again, I go ahead and insert that in. 1/2 of 16 is in fact 8. So my solution is correct. Let's do one more together today. Again, we start off by boxing our variable, drawing our line down from the equal sign. We notice that 4 is being multiplied with x, so to inverse that, I divide. 4 divided by 4 gets me 1. X, -20 divided by 4 leaves me with -5 as a solution. I plug that back in. 4 times -5, negative times a positive leaves me with a negative, and I am good to go.